Hello everyone, in today's video we'll be seeing this question from the year 2021. This is the question from paper 2. So we have to describe the normal and anomalous Zeeman effect and explain how it lifts the degeneracy in hydrogen atom. Let's see the solution. Basically, what is the Zeeman effect? Zeeman effect basically is an atomic energy level splitting in the presence of external magnetic field. So depending upon the magnitude of the magnetic field induction, we have two types of Zeeman effect. First is normal and second one is anomalous. So in the strong magnetic field we see the normal Zeeman effect, and in the weak magnetic field we see anomalous Zeeman effect. So let's see the first type. So that is a normal Zeeman effect. So this is a normal Zeeman effect in the presence of strong magnetic field. So here the orbital and the spin momenta participate separately in the precession around the direction of an external magnetic field. Like in this figure you can see L and S are separately precessing around the z-axis. So we can write the two separate terms which are contributing to the splitting. So this is one because of the orbital angular momentum and other one is for the spin momenta. And we know the GL is 1 and this GS is 2. So we have to note one thing, that the transitions with the change in spin quantum number are forbidden. So the spin quantum number separately is not contributing to the splitting. So we can neglect this spin term. So only the orbital momenta is contributing to the splitting. So we are left with this single term only. In the second type, we have anomalous Zeeman effect, which is observed in the presence of weak magnetic field. Here the bonding of orbit and spin angular momenta remain unbroken. So that's why we are taking the J, which is the total angular momentum, which is L plus S. Here the bond between L and S is not broken. So we can write this mu B, where mu J is the magnetic moment and this the magnetic field. There is an interaction which is creating this splitting. So we can write this is the angle between B and mu. This is pi minus theta. So we can write cos pi minus theta. From this we get mu J B cos theta, and we can write this mu JZ as mu J cos theta, that is the projection of the magnetic moment on the Z axis. And we know the mu GZ, the Z component of the mu J, which is equal to G factor mu B, the Bohr's magneton, and this Mj. Since we know Mj can take 2J plus 1 values, so the main electronic level splits into 2J plus 1 sublevels. So before magnetic field, the states with different Mj have same energy, and after magnetic field, state splits into 2J plus 1 levels. This implies this magnetic field lifts the degeneracy. So let's see this effect in hydrogen atom. Let's take that L alpha line. This is a Lehman alpha line. This Lehman alpha line is going from n equal to 2 to n equal to 1. We are seeing the hydrogen atom. So this is P to S transition. So let's see. This is the diagram. We have P and S. On the left hand side we are seeing the normal Zeeman effect, and on the right hand side we are seeing the anomalous Zeeman effect. So we are having this P to S transition. So we can split this P because the L is 1 for P. So ML can take plus minus 1 or 0. In the presence of magnetic field, P level splits into the three levels plus minus 1 or 0, and S remains the same. We have the selection rule in the normal Zeeman effect, that is delta ML should be 0 and plus minus 1. Going with the selection rule, we have these three transitions. So we are seeing the triplet in the normal Zeeman effect. Whereas in the anomalous Zeeman effect, first because the spin orbit coupling is not broken, so first we have to see the spin orbit interaction. So for the spin orbit interaction, the P level splits into P 3 by 2 and P half levels, and the S remains with a 1 level. So we are doing the J is equal to L plus S. So for P level L is 1, so S is half. So J becomes L 1 minus half and 1 plus half. There's half and 3 by 2. So we have two levels. So first we have done in here, when we are doing the LS interaction, we have our magnetic field 0. We don't have any magnetic field when we are doing the LS interaction. Now when we are applying the magnetic field, you can see there's a further splitting. S level is splitting into the further two levels because of the Mj. Because if J is half and we know Mj can take 2J plus 1 values, so this is 2 half plus 1. So we have two levels here, that is minus half and plus half. Similarly we can do for these two levels by using the 2J plus 1 in how many levels they are going to split. So after doing these number of splittings on the basis of Mj values, now we have to use the selection rule, that is Mj is equal to 0 plus minus 1. Using these selection rules we get these transitions, and we can see that there are several lines in anomalous Zeeman effect. there's more number of spectral lines in anomalous Zeeman effect, whereas there we see a triplet in the normal Zeeman effect. So this is the basic difference in anomalous and normal, and we can see how the both effects work and how these are different from each other. So this is a solution. If you have any problem in this concept, you can write me in the comment box, and if you like this video, please like, share and subscribe to my channel, and thank you for watching this video.